Senjuti, who is faculty in computer science at the New Jersey Institute of Technology. She works in the area of data type things and the World Wide Web. And she is, are you sort of Panasonic chair?
Yes,
okay.
I am.
Okay, she's the Panasonic chair in sustainability and has previously held positions at the Institute of Technology at the University of Washington in Tacoma. She had a postdoc at the Dymex Center at Rutgers, where she and I both were at the same time. So paths have intersected before, and it is a pleasure to welcome Dr. speak to us today.
Thank you, Rebecca. Thank you, everybody. Hi, good afternoon. Almost soon to be noon. Good morning, actually. Oh, good morning. I am Senjuti, as Rebecca mentioned. I am from New Jersey Institute of Technology, and I'm going to talk about one of the major area of research focus these days. So this is sort of the overview of the talk. And since this is a small audience, I would really like to make it a classroom. And so you guys ask me questions and I ask you questions back, and that's how we'll roll, okay? So this is the overview of the talk. After introducing myself and my overarching research areas, I will briefly describe the ongoing funded research projects at my lab, along with a technical deep dive on one of our recent research results, as well as show a brief demonstration of a software that we have deployed to be used at the Navy Research Lab Monterey. I'll conclude the talk by connecting how these research projects has been feeding to my classroom and vice versa. Here is a brief introduction about myself. In recent days, my broader research focus lies in the area of investigating optimization opportunities for the human in the loop system. So I'm the data person, I'm the data management person, and I'm the web kind of a person. I am currently associate professor of computer science with a joint appointment in the data science department. I hold an endowed position as a Panasonic chair in sustainability, as well as affiliated with several institutes and center at New Jersey Institute of Technology. I direct the big data analytics lab at NJIT. Previously, I held a tenure track position at University of Washington and Tacoma, as well as spent a few months as a postdoctoral researcher at Dymex in 2011. And that's how I came to know about Rebecca. So broadly speaking, I focused on the data management opportunities in enabling human in the loop computation and scale. Just let me make my pointer laser. There you go. I identified the key entities in the human in the loop processes as I perceive it, especially in the context of human AI. At the lowest layer, there exist applications. You guys can see the applications. They vary from image recognition to query processing to asset routing. They vary in complexity, need, and nature. The applications attempt to solve problems. That is, they have needs. These needs, basically the goals, are oftentimes possible to be described succinctly through a function. For some other time, they cannot be. For example, a product design goal may be hard to describe functionally. Contrarily, a query processing goal may be easier. These applications generate data. I am a data person by my training. They are voluminous, large, and noisy. They are processed in batches or coming in a streaming fashion. Then there exists model that functionally describe the relationship between the data and the goal. Sometimes this description is as the final goal or some other time as an intermediate goal. Finally, there exists a human whose expertise are varied from lay workers, that is crowd, to domain experts. They both produce data and consume data or insights, and this process repeats. And overarching goal of my research is to understand the data management opportunities from the standpoint of the key entities and design computational framework and system that are principled and scalable. In particular, I focus on the following entities or stakeholders in the ecosystem, as I call them. The first entity or stakeholder are applications that produce or consume data and want to attain high quality, need to be terminated fast, and of course, the resource utilization of these applications must be small. The raw data comes with its unique challenge of scale, noise, volume, and velocity. Next, the workers who are in the loop wants to maximize worker-centric criteria. Some of the worker-centric criteria are money, satisfaction, autonomy, learning, and so on and so forth. The platform, the next key partner in the ecosystem where the interaction between the human and the algorithms take place, are often profit-based. They want to serve as many applications as possible, maximize throughput and worker retention. A unique attribute of my research is to consider the requirement of these stakeholders in unison. Instead of studying them in silo, thereby improving the holistic health of human in the loop ecosystem. That, in a nutshell, is the overarching focus of my research. And here is a quick summary of the prominent research results for the last 4 years or so. While our work is highly interdisciplinary and adapts concepts from social science as well as human or behavioral psychology, we continue to make primary scientific contribution in the data management and data mining community by tapping into our unique strength in building principal models, algorithms, and developing systems that scale. Nevertheless, the work impacts positively the applications in ecology, citizen science, or US Navy, as I will demonstrate soon in the talk. Here are the active funded projects that fall under this big umbrella that we are currently working on. Some of these are studied to optimize platforms and applications, while some others are designed to optimize both humans and application. And we also are working on projects that study both human and platform centricity. At this point, I'll spend a few minutes describing the career project as well as discussing a recent research result in conjunction. This project aims to shed lights in streamlining task deployment in crowdsourcing platforms. Crowdsourcing is the process of obtaining needed services, ideas, or content by soliciting contributions from a large group of people. Such processes are built on private or public platforms, as you may have heard of, like Amazon Mechanical Turk, Crowdflower, Pybosa, just to name a few. Before understanding the project further, let's understand the standard task deployment process in crowdsourcing platform. Typically, requesters here log into this existing platforms such as Amazon Mechanical Turk or Crowdflower with tasks that are to be deployed and want to achieve certain accuracy, latency, cost, and typically follow the pipeline that consists of 4 high-level steps. The first is the strategy design, which is to figure out how many workers are needed, how to leverage the workforce, and in what fashion. Then based on the strategy design, the workers are recruited, following which workers complete the task, and finally the results produced by the workers are aggregated and validated. Currently, this process is mostly trial and error based, and no help is provided to the requester in strategy design. Consequently, requesters are mostly confined to a single platform as there is no easy portability of deployment processes across domains. This project was proposed to bridge that gap with the goal of streamlining task deployment. We propose a middle layer that is scalable, declarative, and have a bunch of other properties that I'm going to skip for now. And it contains 3 integrated components. I want to spend a few minutes describing these components. The first component is the deployment strategy recommendation engine. As you can see here, it is optimized to accommodate multi-stakeholders in the ecosystem and is responsible for modeling and recommending deployment strategies to a batch of requests. The workforce analytics engine analyzes the available workforce and fits to the recommendation engine as the deployed tasks are to be undertaken by the worker. The output of this engine are estimations of workers' preferences, or we call them human factors, such as availability of the workers, either computed deterministically or as a probability distribution function. The result aggregation module, on the other hand here, estimates the quality of the deployed task and fit to the other 2 engines for readjustment. It's empowered by fully automated or hybrid algorithms that sparingly involve human intelligence inside machine algorithms. Now I'm going to do a deep dive, and this is where I would like to hear from the students. For the next 10 minutes or so, I'm going to do a deep dive onto some very specific recent results that are relevant to both workforce analytics engine as well as the result aggregation module of the proposed middleware that I discussed a second ago. This is a joint work with two of my PhD students, Dongwei and Moinul Islam, and a colleague from NJIT. The problem here we study is the following. If we have obtained a ranked list of references from different sources, this could be the task, the requesters, or the workers, how to combine them and come up with a single order that accommodates individual preferences in the best possible way, as well as make the final output fair, which I would define in a minute. This latter aspect, which is fairness, is related to ethics. In this case, studies fairness of existing rank aggregation model. Clearly, this work, as one may realize, is highly crucial in the human in the loop process to ensure appropriate representation of workers or the requester based on their socio-demographic protected attributes, such as gender, race, ethnicity, geographic location, or a combinations of those. The applicability of these research results, however, go beyond human in the loop system, and it applies in hiring and recruitment, search result listing, or even in elections, anywhere the ranking of candidates are the key. In fact, from the intellectual standpoint, we make fundamental algorithmic contribution in studying preference aggregation problems subject to a fairness criteria that could be of interest to many research communities. And now we'll start talking about some basics. Hopefully those will make sense to the students. So rank aggregation, which is a specific form of preference aggregation, works as follows. The inputs to this problem is a set of ranks. So this is a rank, this is another rank, and the output is a single rank, like here, that effectively aggregates the input rank. In human in the loop context, the candidates could be the workers or requester based on multiple criteria, and the goal is to generate a single order which may be used to come up to order workers or specific tasks, or coming up with an appropriate order of preference of tasks coming from different requesters. Now, as I have mentioned, that the goal is to combine multiple ranks and come up with a single order. But let me start this by giving a bad news. And this news is comes from the Arrow's impossibility theorem. Arrows is a celebrated economist, and he got a Nobel Prize, I think in 1972, if I'm not wrong. And this theorem simply says that no rank aggregation can convert the rank preferences of individuals into a community-wide ranking while also meeting a specific set of criteria. And there are not many criteria, only 3 criteria. The Arrow's impossibility theorem says that there doesn't exist a rank aggregation function that satisfies all 3. The first is the non-dictatorship. It's pretty easy to understand. It simply says that no single voter should possess the power to determine the group's preference or the group outcome. The second is the Pareto efficiency, which means that if every voter considers candidate A to be better than B, then the aggregation rule must rank A above B. And the third is independence of irrelevant alternatives. Simply means that if A is ranked above B or vice versa, then the outcome should depend on how different voters have ranked A compared to B, and not a third candidate and how that candidate C has been ranked compared to it. Okay, so very simple criteria, and surprisingly, these 3 simple criteria are not met considering any existing ranking function. So it's a negative result, but this result it's a celebrated results, and people who study rank aggregation, which is studied big time in social science, they try to come up with criteria and show that how different rank aggregation methods may or may not satisfy this criteria. I mean, not all 3 obviously, but which of or one of them they satisfy. So now I want to talk about a specific way of computing distance between 2 ranks, and it's called Kendall Tau Distance. Okay, the Kendall Tau Distance is the notion of Kendall Tau Distance is very simple. Here I give you 2 permutations. Permutation in order. So I have sigma and eta. They all both are defined over n candidates, 1 to n. And What Kendall Tau Distance computes is that it computes the number of pairwise disagreements between these two ranked order. So if you look into sigma and eta, you can find that there are 3 pairwise disagreements between sigma and eta. In sigma, Molly was ranked before Amy, and it has been reversed in eta. In sigma, Molly has been ranked before Kim, that got reversed in eta. And in sigma, Abigail is ranked before Kim, which got reversed in eta. So the Kendall Tau distance between sigma and eta is 3. And therefore, given two rankings, I can calculate the Kendall Tau distance by just computing the number of pairwise disagreements. Okay. And this is the measure that I will be sticking to for the next few minutes. And why? Even though this measure is simple, this measure actually does satisfy some good, cool properties. One is the Condorcet property, or the Condorcet winners, which says that elect that candidate who wins a majority of the vote in the head-to-head election against each of the other candidate. That is, if a candidate is preferred by the majority of the voter, that candidate should win the election. And these properties satisfied by Kendall Tau. The other reason of using Kendall Tau is its good mathematical property. Kendall Tau is a metric distance, and it satisfies triangle inequality property that you guys may all have heard of by now. Now, generalizing Kendall Tau, when I have not just 2 ranked order, but a set of m ranked order. So given ranking row 1 to row m, the generalization of Kendall Tau is the Kaminer distance, which is nothing but the sum of Kendall Tau distance of every 2 orders. Okay, as simple as if I get sigma, which is a ranked order, and row 1 to row m are the input ranked order, then the Kaminer distance is the sum of Kendall Tau distance between sigma and each of the row i's. Okay, so this is the distance measure that I will be sticking to, and this is a good distance measure because it satisfies some good properties. Now, the second facet of this problem is to ensure fairness in the protected ranked order, considering group fairness criteria. So we are doing rank aggregation considering fairness. Group fairness are typically defined on protected attributes of the candidates, such as gender, ethnicity, and race. And the fairness ensures equitable representation based on the proportion of the candidates in the original data. So on the left side of the slide, you can see there is a protected attribute gender, and based on the protected attribute gender, this is how the candidates are ranked. Well, I'm not saying this is a fair ranking or not, but this is the rank and the corresponding protected attribute gender-wise representation of the individuals. On the right-hand side of the slide, you get to see there is another order, well, actually the same, a different order, where the candidates are ranked based on another protected attribute, which is their race. The difference between the left and the right side is that, of course, the order of the individuals are different, but more importantly, this attribute, which is gender, is written here as binary protected attributes. We did not consider non-binariness. On the other hand, the race is a multi-valued protected attribute, meaning it has more than 2 possible values. You can see here the 3 possible values we can see straight out is Caucasian, Asian, and Native Hawaiian compared to male and female for the gender. Are you guys with me so far? Now, we study fairness considering P fairness criteria that I'm going to define now. P fairness represents temporal fairness or proportionate fairness. The classical problem in this context is known as the chairman assignment problem, which studies how to select a chairman of a union every year from a set of n states, such that at any time the accumulated number of chairmen from each state is proportional to the weights. Well, I should not be calling it chairman anymore. I should call it chairperson. But when this was studied, they call it chairman assignment problem. And this chairman assignment problem, it's an old result. It's a old work. It came out in 1980. In the context of ranking, for us, the goal here is to ensure proportionate representation of each protected attribute value in each of the ranked order. The exact proportionate representation is between floor FP times K to ceiling FP times K for the kth position, where FP is the proportion of the Tth attribute value. As an example, if proportionate representation of male and if proportionate representation of female is needed to be 50%, then at the first position, I need at least 0 female and at most 1 female. For the second position, this requirement is 1 and 1 respectively. And for the third position, this requirement is 1 and 2 respectively. Based on that, the provided ranking of Amy, Park, and Molly with 2 female candidates in the top 3 position is actually P pair. Okay. So what we are trying to do is that we are trying to, given a set of input ranks, we are trying to come up with an aggregated order, but not only that, we want to do that in a manner such that the P fairness is preserved. So extending this example further, the left rank does not satisfy proportionate fairness because in the top 4 positions, you have 2 male and 2 female in the top 4 position. It does not satisfy that. It has 3 female and 1 male. So it does not satisfy the property. In the top 6 position, it does satisfy though, because it has 3 male and 3 female. Contrarily, the right-hand side one does, because in the top 2 position, you see 1 male and 1 female. In the top 2, you see 2 male and 2 female. And in the top 3, you see 3 male and 3 female. Okay. So our goal here is to, given this set of input rank, how I can come up with a single rank that is closest to the individual preferences as well as satisfy P pairs. And to be specific, these are the 2 problems that we study. We study given a ranking row and a P pair, find a P pair ranking that is closest to row in Kendall Tau distance. And then the rank aggregation, which is a generalization considering P fairness, given M rankings row 1 to row M, find a P fair ranking that minimizes the Kamenian distance to these M rankings. And now comes some boring stuff. May not be that boring, but these are the variant of the problems that we study. We study these 2 problems, one we call as IPF and the other we call as RAPF, considering binary and multi-valued protected attribute, because we realize that depending on whether the protected attribute is binary or contain more than 2 values, that will change in the nature of the algorithm design. So we study both the variants, and for the binary protected attribute, we realize it's an easy problem and we can design an exact greedy algorithm, which is much more efficient. For the multi-valued IPF, the problem turns out to be much harder, and we have an exact solution which is designed using dynamic programming, which can be exponential at some point, as well as a provable approximation factor algorithm, which is much faster. For the RAPF, for the rank aggregation problem, we design both randomized and deterministic algorithm, and we show that these RAPF solutions actually leverage the IPF solutions as subroutines. The RAPF and IPF, they both have different approximation factor, as I will summarize next. And this is sort of the theoretical results of the work. It might appear a little terse at some point, but what we show here is that the IPF problem for the binary is a p-time problem, and we can design an exact solution, which is quite efficient. For the multi-valued, the NP hard, the hardness is currently open, although we conjecture it to be NP hard. And we have 2 types of solution. One is an exact solution based on dynamic programming, which is exponential when the number of protected attribute is a variable. We also have an approximation algorithm with 2 approximation factor that is designed based on matching, and that is much faster than the exact solution. The RAPF, again studied considering binary and multi-valued scenarios, are NP hard nevertheless, because rank aggregation under Kamenian distance is proved to be NP hard in prior work, as long as there are more than 4 or more than 4 input ranks. And then we have a suite of algorithms that designs that leverages both deterministic as well as randomized solutions to come up with the provable approximation factor as well as their corresponding running time. In fact, one of the solid technical results of our work is that we prove that we have just come up with a framework for the RAPF problem, which exhibits the 2+ approximation factor of the IPF solution. So if we can design a good solution for IPF, the corresponding RAPF will be +2 approximation factor of the solution of the IPF solution. How am I doing with respect to time, Rebecca?
We try to finish up at 12:30, even though we started late.
Okay.
You guys all
Have a class. Okay, wonderful.
Sorry about that.
So I want to say at this point is that while I won't be able to dig deep on this, but this notion of fairness is stronger than the existing state of work, so state of the art. So we advance the state of the art non-trivially. And here are some work that I have laid out. One is a recent KDD paper, the other is a recent VLDB paper. The KDD paper studies generally the IPA variant of the problem, but does not produce, consider proportionate fairness considering both lower and upper bound. Whereas compared to this VLDB paper, we promote a stronger notion of fairness, and we design a more efficient solution with provable guarantee compared to an integer programming, which is exponential, that is designed in the VLDB paper. And I have a couple of slides on the algorithm, which I'm going to happily skip for the interest of time. I want to spend 1 minute on the evaluation. So as Rebecca mentioned, I'm a data person, and we cannot publish a paper without showcasing that what we are claiming theoretically actually does work in practice. And that means rigorous evaluation using real world data set. And if you don't have large enough real world data set, you have to evaluate it using large scale synthetic data set just to ensure scalability, because I'm a data person who cared about scalability a lot. So what we showed here is that we have a bunch of real world data set, as I am listing down here, as well as synthetic data set. You can see that synthetic data set is much larger in size compared to the real world data set. And we showed that the designed algorithms demonstrate better approximation factor compared to their theoretical bounds. We produce rank that always satisfy p-fairness, whereas the state-of-the-art solution do not. I mean, to be honest, the state-of-the-art solution was not designed to satisfy p-fairness, so it's not surprising. And the designed algorithms are highly scalable, as demonstrated by the experimental evaluation. Okay, so now I'm going to go and move on to another project, and it will see that compared to the rather theoretical nature of the first project that I described, this one is more applied. And this is a project that is funded by Navy Research Lab, and that's funded by Office of Naval Research, ONR. And I'm a ONR performer for last 2 years with multiple projects. And this project actually tries to exploit the synergy of hybrid human-machine teams for effective decision-making via multi-objective optimization algorithm for agile mission planning to provide proactive context-dependent decision support with enhanced operational capability under uncertainty. So a lot of keywords I have thrown, but what we have done in reality is that we have developed an adaptive, distributed, semi-supervised team decision-making framework for efficient asset routing. The developed solution emulates the real-world concepts of operation, or CONOPS, that is very important for Navy asset navigators, and it enables scenario thinking to enable decision support. Again, for the interest of time, this is sort of the high-level problem that we have come up with. The problem is how we study how to guide the navigation of n cooperative assets with respective starting points over a discrete grid to discover an initially unknown destination, such that it optimizes multiple objectives while avoiding collision. There are a bunch of constraints that are part of these problems, but this problem is formalized as a constraint Markov decision process, and we design a reinforced learning-based solution to solve this problem. With all the complications aside, As a data person, I also study the memory bottleneck and the scalability challenges through function approximation, and the details of these work could be found in the Sigma 2020 paper that just got published. So what I'm going to show now is the fun part. I want to show you that how this, since this is a software that is deployed at Navy Research Lab, how this software works in reality.
This demonstration shows how a Navy asset operator can make use of this developed decision support tool for planning paths of multiple ships in a complex, uncertain environment. To start this demo, let's log in. Upon logging in, the user, or navigator, is presented with multiple scenarios to choose from. I will pick scenario 2 for this demo. Upon picking the scenario, I'm directed to the global view. The global view shows the different assets, their start points, the destination, as well as the different hazards. The hazards and the assets have been color-coded for ease of sight and to also show the severity of these hazards. We can also choose to zoom in to one asset in particular. Let's pick asset 1. Upon doing so, we're directed to the local view for asset 1. Here, we see the feasible routes for asset 1. And these routes can be ranked based on weights allocated by the user. The replan option shows routes that would allow asset 1 to avoid this hazard. We can click on these routes to visualize them, as well as see the CDF. Let's go ahead and select route 4 to avoid this hazard. Upon clicking accept, the route will be updated. Let's go back to the global view to see how that would look like. And as you can see, asset 1 no longer encounters the hazard that we previously saw. This concludes an end-to-end working of this decision support tool. This decision support tool would allow Navy asset operators to plan routes for multiple ships in a wide range of complex and uncertain environments. Thank you.
Okay, so then I actually have a condensed version of a bunch of other funded projects. And since Rebecca said I must stop at 12:16, I'm actually going to skip all of them, if that is okay. I will just give you a quick flavor that they vary in nature and type. Like the first one that is designed, that is funded by National Science Foundation, it studies how to involve lay workers in designing optimization framework for creating attributes in data science pipeline. So those who have taken a data science class, probably none of you yet because you are a freshman and you are a sophomore, you know that the data science pipeline starts with data cleaning, data processing, and then attribute design, meaning that from the raw data, how you can create attributes that are suitable for the underlying model. It's a challenging process. And these processes are usually designed as two extremes. Either they are fully automated or they are fully manual. And you can see the problem in both sides. The fully automated side lacks of explainability. They are very opaque. And the fully manuals are slow, more expensive, and so on and so forth. What we do in this project is to take a middle ground and show that if you use not domain experts who are very expensive, but let's say you hire less expensive humans, such as undergraduate students or graduate students, how you can scale up this process, yet create interpretable attributes quite efficiently that are more scalable than fully domain expert created handcrafted attribute, as well as they are more interpretable than fully automated attribute design processes done by deep learning, for example. And as a technical contribution, it talks about algorithms and some frameworks which can design human feedback and human insights sparingly to make this process scalable, effective, as well as efficient. So I'll skip all the details. And the next one is, again, it's another Navy project and it's very different in flavor. So I want to spend a couple of minutes on this. This project studies it's an acronym. It's predictive analytics on ship schedule, and it's a very high visibility project at Navy because every time we give a presentation, there are some commanders who sit in our presentation. And this project actually studies that how to enable ship scheduling efficiently in naval shipyard. Apparently, after every Navy ship is deployed, they go for periodic maintenance in the shipyards. And this maintaining process is chaotic, to speak the say the least. And they always go out of schedule because there are multiple factors and multiple organizations who are involved in the process. And this causes late returns of the fleets in the base, causing late deployment process and causing a lot of loss, cost, and other monetary wise. So the goal of the project is to determine the key drivers, which will cause a scheduled maintenance to go out of target, and figure out how we can design decision support to keep the maintenance on target. And I'll skip the rest of the details. And another one here, again, a very different in nature, but still fall under the big umbrella of human and AI. It studies an human machine intelligence framework for single and multi-level classification problems through active learning. And here the project focuses on citizen science-based cyber-human system to collect species observation information from ecological application, but the findings apply more broadly. I mean, this project offers a lot of intellectual contribution, but I want to take a few minutes to describe the impact of the project. The project is actually currently going through a pilot study on iNaturalist platform. I don't know if you guys are aware of iNaturalist platform. It's a social network of naturalists, citizen scientists, and biologists built on the concepts of mapping and sharing observations of biodiversity across the globe. It's very large. It has 4.8 million registered users, more than 90 million observations, and 350,000 species observed. And here we are designing this study on iNaturalist platform to see how to enable automated crowdsourced citizen science-based species observation on that platform. And the final project that is, it's a planning grant. It has a completely different scope. This studies that how we can accelerate data science application on streaming data. This is a planning grant that is designed with a collaborative team from NJIT, USC, and Harvard, who have expertise in distributed system and parallel processing, computer architecture, as well as efficient algorithm design and application. Basically, the goal of this project is to understand the holistic health of streaming processes, from the applications to data to hardware, software, co-design to computer architecture, and figure out that how to design, how to enable design technical solutions such that the holistic health of streaming applications could be expedited and be made more democratic across different applications. So that's it. And I want to summarize what I talked about. I am a data management researcher who studies how to promote synergistic relationship between human and AI. And I'm deeply passionate to understand this relationship in the context of future of work. And just to give you guys a little background of that, I have been involved in several future of work related initiatives in the past few years, including a co-moderator activity in Sigma 2021. We also have done a 3-day-long workshop in Shonan, Japan, understanding how future of work and big data can change and speak with each other. As well as we have written Sigma blog post, and several publications came out from these aspects. And finally, not but the list, I want to spend a few minutes on teaching and outreach. Classroom is still one of the places that truly excites me, as I enjoy the challenges of explaining the fundamental concepts to the students. And I feel inspired when I get to see the transformation that learning brings to my classroom. And I typically teach data-centric courses as well as algorithm courses at NJIT. And I foster an attempt to design student-centered classroom and try to take the role of the guide on the side. So I only intervene when I need to. I also have made a sincere attempt to constantly try and bring in the research into the classroom by designing course project, homework, and other assignments that complement my research activities, which in turn brings renewed energy and interest among my students, including myself. Additionally, I want to mention one particular initiative that I have been leading for the last several years that is related to outreach. This involves our computer science graduate program, our honors college at NJIT, as well as a high school, which is at the Union City. It's called Union City High School. This program engages groups spanning from K-12 to PhD students to foster the development of necessary practical skill while encouraging independent critical thinking through hands-on interdisciplinary research opportunities. And every summer, I actually design workshops involving students of all levels to promote peer learning and mentorship. The workshop foster mentorship and peer collaboration among students through hands-on tutorial session, poster presentation, and lightning talk. There we have demonstrated how to design, deploy, and analyze data science solution for different applications, starting from tweet annotation to sentence translation, to students collected water samples to understand the environmental pollutants to attract the students to interdisciplinary research and STEM. That's it. I want to conclude my talk by giving a shout out to my amazing crew, my students, as well as my lab. And I would like to acknowledge the funding agencies who have been funding me. And without that, none of these would be possible. Thank you. And time for quick questions.
I was wondering about the priorities the ranking. I was wondering if that was companies, people.
Yeah, it's a great.
Repeat the question because I think we're only
Yes.
your audio.
Yes. So what she's asking is that your name. I would like to put a name on the face. Mawani.
Yeah,
So Mawani asked a question that at the beginning of the talk, I described ranking, and she's asking whether this ranking work has found any real applications in the companies and so on. It's a great question. That's what you asked me, right? Yes, and I think this ranking application that we described, ranking process that we described, has wide variety of applications in many places, including credit card approval, as well as faculty recruitment, or even in college admissions. Okay. In fact, the New York City school admission process could leverage some of this. In terms of how much we have accomplished some of these or not, we are in conversation with some of the banks, which does automated credit card approval, and we are trying to see if we can pilot some of our design solution to their processes.
We've got a question from Yana on Zoom.
Hi, thank you for your talk. My name is Yana, and I wondered, for the projects that you do, what would you say is more important to get right, if I can say it this way, the data mining or the algorithms themselves? Like, what is the percentage of when you work on a project, how much time would you put, like the team, on the finding the right data or actually putting the right application on it?
So finding data is always important, but I come from a background who is interested to explore principal solution to the problem, and that's what DIMAX has given me. That's what my PhD training has given me. So it will not be fair to tell I focus only on data and application. I think my focus is to find good application, compelling applications where principal solutions makes a difference, if that makes sense.
Yeah, thank you.
Thank you again.
Thank you. You guys are actually amazing students. I could see that. I mean, after 10 years of being in the classroom, I can